Welcome. My name is Natasha Sherman and I am your host. And my guest today is Dr. Vincent Kiechlin. He is a chiropractic neurologist. He's been my guest before, but I keep having him back because he has a ton of valuable information. Welcome back.
Thank you.
So for people who don't know, let's talk about what is a chiropractic neurologist.
Well, chiropractic neurologists are chiropractors that have specialty training in neurology, and you have to sit for a board and pass the board and everything else in order to become board certified.
So today we're definitely going to talk about brain trauma, but let's talk a little bit about why people come to you. You know, Dr. Carrick, who you've studied with,
Yes.
who is kind of, I guess, the guru of chiropractic neurology at this point.
I would say so, yes.
He said his treatment involves reactivating pathways in the brain, what scientific circles refer to as neuroplasticity, by stimulating other parts of the body. He is considered the main architect of chiropractic neurology. But one of the things he talks about is that, you know, some people say, oh, what you did for me is a miracle. And he said, I think miracles are things that happen once in a while. What we find is that the miracles that we see, we're seeing them frequently, every day. So they're not really miracles. What we do is amazing because of what humankind can do, but we just combine different things that other people have done in a different fashion. Would you describe it that way?
Yeah, that's a very good description of it. Basically what Dr. Carrick has discovered is how chiropractic worked. And I believe that's how he originally, he figured out how it works, and then, with understanding those concepts, you can extrapolate even more on how the brain works and how other types of therapies work, and it's made it very valuable in helping people.
Yeah, so ideally what you're after is when somebody comes to you, and we're going to talk about what kinds of people come to you, but what your aim is to balance the brain, because the brain kind of sources the rest of the body, yes?
Yes, that's correct. Balancing the brain, and also, basically improving function where there isn't, and that's really important.
Ah, yes.
Because sometimes both sides of the brain aren't so hot either. So you always want to try to improve function, but because of how the brain oscillates in function, then that is very important, that the brain is balanced in activity. It's very important.
Yeah. So what kinds of conditions do you treat?
Well, because I'm a chiropractor, I see a lot of people with spinal problems, of course. But the spine is basically used as a tool to change the brain, because it's a tremendous stimulator to the brain. It's just a massive sensory organ, and the biggest thing that it senses is gravity and spin. And it helps us resist that in gravity, and you're always in gravity. So the spinal muscles are always on, they're tonically contracting all the time, even when you sleep. And so therefore they have a constant effect on the brain.
Wow. And what kinds of things would destabilize that?
Well, injuries, of course, to the spine. Head traumas. It's very difficult to bang your head without not injuring the spine and the neck, particularly at the same time, because it's attached to it. The head is very heavy, something you learn when you go to chiropractic school. You can't believe how heavy people's heads are when you first learn to palpate the neck. They're extremely heavy, but because, a blow to the head is always going to have an effect on the neck, then there's always a rotational and twisting motion, almost with all head traumas.
Wow.
Very few exceptions.
So if so someone here at the studio just recently got hit. He was on his bicycle, and he had a head trauma. So they did an MRI of his head, but I didn't hear him talking about his spine. So I think most people expect a head is just in the head.
Well, the spine is a big sense organ. It compensates for whatever injury happened when you hit your head. Most of the time, at least from my experience, is that when people hit their heads, because of this bending and turning and twisting motion in the neck, because your spinal cord goes up through your spine into the base of your skull, and the brainstem is right there, that brainstem gets twisted, and so therefore the receptors coming into that area, which are mostly your inner ear, they also become disrupted, or the connectivity between them becomes disrupted, And so people lose that sense of where they are in space. And where you are in space is the primary function of the brain. It does that before anything else. And a good example I was describing to a patient recently was that I remember as a child sleeping at my grandmother's, and I can remember opening my eyes in the morning for the first time, and I was startled. I can still remember being startled. And then I was like, oh, that's right, I'm in Brooklyn. You know, I'm at my grandmother's, I'm in my uncle's bedroom. But why? Because when I opened my eyes, and people get this at hotels when they stay at hotels, etc., they forgot because they got startled, because that's how quick your brain finds where it is in space. And when you're not where it thinks it should be, it startles you until you orient again.
Wow.
So I find that a lot of these people who bang their heads lose that, and you can see it. You can measure these things in exams.
So, and it seems to me also that sometimes people will get hit, and I remember even my kids, you know, banging their heads, and you think, oh, kids bang their heads, you know, you stop the bleeding and you don't think about concussion too much. But what are some of the symptoms that aren't obvious that could then be something that really should be addressed?
You know, sometimes people, you know, the common symptoms are typically people who have difficulty reading, or they get eye strain. And why? Because your eyes are one of the big compensators when you are not oriented in space properly. So you tend to compensate with those, so they're working extra hard. And people a lot of times don't even realize they have eye tracking difficulties until you measure them, and you realize that instead of following objects smoothly, their eyes jump. And when your eyes jump, you're actually blind for that split second that your eye jumps. So they just start having, you know, difficulty reading, and they'll get headaches when they read.
And they might not associate this with that.
No, often they don't. Sometimes they'll have memory difficulties. They'll have personality changes that they're not aware of. I had that recently in a young man who's 15, 16 years old. And his parents realized, hey, something's not right with this child. His friends told the mom something's not right with him. He didn't even realize it.
Wow.
So.
And then, so how do you treat that?
Well, you do a good exam, and you basically try to improve function where you see it's lacking, and see if that relates to their symptoms. So, for instance, one of the things that I test for cognitive deficits, you know, there are lots of questionnaires that you can give people to test for those things, and they're very beneficial and helpful. But being a chiropractor, I like to use motor signs, you know, muscle movements, things of that nature. And dual tasking is a signature for cognitive deficits. In other words, so dual tasking example would be, I'll ask somebody to walk and ask them to count backwards, or say a calendar backwards every other month, something to that nature.
Oh, you asked me to do that. I was bouncing off the walls.
and you'll see that people's gaits will change. And it really shouldn't change that much if you don't have cognitive deficits. And I'll have some people who'll completely freeze mid-stance or mid-gait, mid-swing.
You know, I think the part of me that gets concerned is that if we're not marrying the event to the symptoms that may not be related, we just kind of deal with it. It just becomes part of our lives.
That's very typical in initial head traumas.
Yes.
So typically, you know, if you read some of the literature, you'll see that secondary head traumas are usually much worse than initial head traumas. And the reason being is that after an initial head trauma, your body is very good at recompensating, or basically your brain will rewire based on the lower functioning area. It'll get other areas to compensate, other areas of the brain, I mean, to compensate for that loss of function. The problem with that is if you get a second concussion and you damage those areas that have compensated, you don't have anything else to compensate with anymore. And a lot of times, you know, the secondary concussion is usually very minor. It'll be a little ding on the head, so to speak, is often how it's described. Nothing like the first one, yet, you know, I'm so much worse from this one, is a very common complaint.
It's interesting that you say that. I just saw an interview of someone who was an athlete, a young woman, and she had a secondary concussion 20 days after the first one. And it's like her whole body fell apart.
Yes.
She was almost non-functional.
That's very common. It's very common. So how do you start? You look and see where isn't there function? Can I improve function? You know, doing certain things, giving them exercises, adjustments, whatever I think is appropriate or what I find is appropriate.
And this is all not with medications?
No medication for any of this.
Yeah, which to me is always a big win.
Yeah, always. I mean, a lot of them are taking meds when they come to me, but
right.
it doesn't have an effect on what I do.
Right. Oh, good. So let's talk about neuroplasticity.
Okay. Well, neuroplasticity is a magical activity that the brain performs after a head trauma or something of that nature. But basically, neuroplasticity is really the basis of all learning. And what it is when the cells are stimulated in the brain from the environment,
right,
they physically change as a consequence of that stimulation. And they're changing to adapt to whatever change has come in. So the brain loves change. So frequency of exercise is much more than single long-term types of exercises, because with a long-term exercise, the change isn't there anymore. The brain adapts to it. So with frequent stimulation, the brain it is attracted to that. It likes change. Huh. So almost like a good example would be if you're in a hot tub.
Right.
And you first get in, it's really hot, and you're in there for a good 10 minutes or whatever, and all of a sudden you're getting a little chilly. Mm-hmm. So you turn up the heater a little bit, and that doesn't really change. You're still, not feeling that change. So the best way to make the water hot again is to get out of the tub, cool off, and then get back in. So the brain loves that constant frequency of change. So neuroplasticity is a frequent change. That's what happens, is the brain actually physically changes when it's stimulated. And so it's one of the ways that the brain heals itself from concussions and head traumas, but it's also the basis of all learning. So when you go to school, it's how your brain learns school, but it's also how your brain learns motor activities. It's how it learns where it is in space. And I talk about that a lot because what people don't understand is 90% of all your brain activity is really unconscious, meaning you're not even aware your brain is doing it. Only a small portion, 10%, is actually conscious awareness. And so orienting in space is something your brain immediately does, and it's the primary thing it does first before it does anything else. And just ask anybody who's dizzy. When you're having a vertigo attack, what can you really do when you're having that attack? Typically, not much, because you're not oriented in space anymore. And so it can be really extremely frightening for people.
Yes, and even dangerous.
And dangerous, of course, because you can't coordinate your muscles, you can't do anything.
So what do you do with that? And where does neuroplasticity come in? Because it's interesting, you say the brain loves change, and I could get that. And you could see it in children growing up. I mean, they're learning something moment by moment, and then
Constantly.
We kind of seem to get stuck and frozen. And then we as humans, your brain loves change, but you don't want to change.
Well, I mean, plasticity is the tool your brain uses. Think of it this way. It's the tool your brain uses to adapt to the environment, and it's something it has to constantly do all the time. So right down to having breakfast that morning. You consciously, shovel it in, but once it's gone past past your throat, that's it. You don't think about it anymore.
Right.
Yet all this brain activity is going on to turn that into something your body can use.
Yeah. So again, how does neuroplasticity relate to the average person and someone with a concussion?
Well, neuroplasticity for the average person, like I said, you're using it all the time. So when you do any type of learning activity, it's why, keeping busy is really important, because you're using your brain. They know that, I'll give you a statistic, that people, the higher your form of formal education, or the higher your level of formal education, the less likely you are to get Alzheimer's and dementias. And why is that the case? Because typically, if you've reached a certain level in education, then you're going to use that education in your job. And so you have to constantly use your brain in your job. And that's a very, long-lasting thing for the brain. So that's something that the average person can use. But if you don't have a job where, that's the case, then, doing puzzles and things of that nature and just constantly pushing yourself to challenge yourself cognitively. I remember speaking to some friends years ago, and we had laughed a little bit because a lot of them were saying how, yes, since I left college, I haven't read a good, book or a lot of books in a long time, and reading is a fantastic brain activity. Fantastic. It's pure frontal lobe. It's very human. It's why humans can do it and other animals can't, because we have a special area in our brain they don't have that allows us to do that activity. So it's really, really good. It's why walking is so good.
Why is walking so good?
There's basically 5 motor activities that people do that other vertebrates can't do, and walking upright on 2 limbs is one of them. And why is that so special for people? Because balancing on 2 limbs is much more difficult. So our bodies sway more as a consequence of that, and that shakes our inner ear. Inside our inner ear, there's plates in there that are piled with little crystals that have all these hair cells that fire impulses into our brainstem. And without getting too technical here, when you stand up on 2 limbs, they're constantly shaking so fast, 8 to 12 times a second, that we look still. Again, this is that automatic thing that you don't have to think about.
But you're using it and it has an impact.
And it has a huge impact. So walking, in order to walk, you have to balance on one leg in order to take a step forward. And so therefore that system has to work fairly well, and it's a fantastic way to exercise it because your vision is involved, all your limbs are involved, your breathing is involved. It's the best exercise really for you.
Wow. So I have a
As long as it's not done too long.
Okay. So, and then I'm going to ask you what too long is, but you talk about kind of use it or lose it, and we kind of pay lip service to that. But when people retire, I'm not sure people who retire are that prepared to keep their brain engaged.
A lot of people do have difficulty with that when they retire. Excuse me. So I would recommend with those people is understand that if you're not engaged cognitively, then you want to engage in a motor fashion. So what does that mean? You want to stay as active as you can. If you have arthritic joints, try to get in a pool where those joints won't become such a problem. But there's very low impact activities, yoga, tai chi, all of these things have been studied by all different researchers, and they've all shown to change the brain in a good way.
Wow.
So, but the reason being is because they all promote neuroplasticity. They all promote that constant connectivity. Neuroplasticity is a two-way sword. If you don't use those areas of the brain, they'll retract, they'll retreat also, because all of these branches that these cells make to become more efficient require energy, and if you're not using them, then that's energy that can be used somewhere else in the brain, and the brain will retract them. So you want to constantly, that's why walking is such a good exercise. And what I meant by not too long is that plasticity will always occur, always, which is pretty amazing, but it will always occur as long as the cell is not overstimulated. If you overstimulate it, plasticity actually doesn't occur at all, and that's really important. So I recommend exercise that is frequent for short duration. It can be intense for short duration, but it should be for short duration, primarily.
Right.
There are always exceptions, but, and for that reason, if that's what you're trying to do is grow your brain and make your brain healthier, and the motor system is one of the best ways to do it, especially in children, because they're such motor and sensory beings that their brains are just, they love that stuff. So it's a fantastic way to help them cognitively, because the same parts of your brain in most aspects that move your muscles think.
So I want to leap around. I just heard somebody being interviewed the other day about, aging, and one of the things that they said was, whatever you find yourself saying, I'm not good at, That's what you should be learning. I'm not good at reading for longer than 10 minutes. I'm not good at memorizing. I'm not good at languages. I'm not, you know, those are the things that you should try to get good at. Is that?
For the most part, you always want to try to enhance your weaknesses because those are reflections of what's going on in between your ears. But sometimes people are definitely attracted to things they're good at. I find people take jobs in areas they're good at. It may not have been what they studied in school, but they definitely will take things that they're good at. And I don't know if I answered your question.
Yeah, they're still utilizing their brain.
Absolutely,
yeah.
No question.
But I think the most significant point is don't ever stop trying to stimulate your brain.
No, you always want to, you want to try to stay as active as you can.
Yeah, because this whole vegging out with the clicker and all of that, to me it occurs like...
The problem with a lot of screen watching is there's not a lot of motor activity. There's a lot of eye activity, like they've shown that with video games, and actually I just saw a recent study that showed that they're now using video games, or trying to anyway, they're studying if it can work, to help people with dementias. And so it's not surprising because when you play games, there is motor activity involved.
Right.
There's eye tracking, there's hand movements, and those do change the brain, no question.
That occurs to me like a training rather than an addiction.
Yes, and you're probably going to see more of it and more of it. They've shown that people who have paralysis, I've read studies where they'll watch slalom skiing, and it will actually, they'll put sensors in their legs that are supposedly, inactive, and the sensors will become active even though they're not using their legs.
Wow.
The brain is almost imagining it. And again, it has a lot to do with that automatic part of your brain, that spatial part of your brain, which I could talk about for hours.
Yeah. There was another question about what you said. Yes. What about, so, you're saying, when you were talking about kids, and they're active and they're learning and their brains are forming, and you don't have to tell them to do this. But what's happening with children now, very often, and I don't want to make a blanket statement, but it occurs to me that for a large part, children are less physically active than, let's say, we were when we grew up.
It's probably true, although, now the thing to do with your children typically is you put them in some kind of sport after school, or some kind of activity, clubs, chess club, ping pong, all those types of things. But, we had a little bit more freedom. I know I did it when I was a kid than my kids have today. I have 4 children and they don't have the same freedom. Yeah. But they're very active in sports and all of those things.
So that's important.
It's very important for children.
I wanted to ask you about reading. You were talking about how reading is really good for the brain. Does it make a difference if you're reading from a book and from a screen?
They know the brain does read differently from a screen than a book, but they don't really know if one is better than the other. The jury is still out on that.
Okay.
Because you still use very new parts of the brain. The human part. When I say new, I mean the parts other animals don't have.
Right.
To create those types of activities. So, but the brain does absorb it differently, and the jury is out. There's a lot of debate on that.
Right.
On both ways.
We have a few minutes left. Is there anything else you wanted to say about concussion and neuroplasticity? Well,
what I find with concussions is that a lot of these people, for whatever reason, their injury, one of the things that they found, there's special types of MRI units. MRIs are a type of imaging of the brain where it creates a computer-generated image, and they have ways to manipulate the image now where they can show activity not just in the regions of the brain, which is how it's been for probably 2 decades now, but now they have ways to image the activity in the pathways, and that's very new.
Right.
And the reason why that's so important is what they find is when they image these pathways, especially coming down through that brainstem, is that there's a twist in those pathways, and that twist is not normal. It's not supposed to be there. They're supposed to go straight down. And to me, that twist is evidence of that, you know, that bending and turning when most head traumas
Right.
occur. And so basically one of the best ways, because those areas of the brainstem are associated with balance and posture, is a really good way for someone who has a concussion is to try to do some walking. You know, those are simple things that somebody can do, but I mean for very short, may only be a few minutes. I don't mean walk a long distance, because some people can't handle it, especially if you have spatial awareness.
Right.
But that may be something that that's very helpful. You know, other than that, you really need to know where is the weaknesses, where are the strengths, and can those things be changed.
And you work with people to do that.
And that's basically what I do.
So we have a minute left. What message would you like to leave us with?
Learn more about the brain. There's a lot of educational shows. You know, just on the TV. The Science Channel is great for that, I find, if I can say that on TV. But those are really, you know, and learn more about your brain. It's what makes us so different than other beings. It's what gives us compassion. It's what makes us human and different from other beings. And always take care of your brain. It's really important that you do so.
Yeah, and I think that's really great advice, because mostly we take our physicality for granted. I can walk, I can eat, I can do this, until you can't. And so the brain is not something, if you haven't had a concussion, usually you're not thinking, oh, let me check out my brain. But
that would be true.
But it's worthwhile, because there's brain health, and there's what
question.
you can do to strengthen. And,
absolutely.
Yeah.
You're going to see more and more of that as time goes on, in the popular press for sure. It's already happening.
All right, so we're at the end of our show. Thank you for coming back.
Thank you for having me.
And we'll be posting this up online soon. I invite everybody to check it out.
Thank you so much.
My name is Natasha Sherman. Thank you for joining us.